so I expect only a few people. Okay, hello everyone. This is Postgres TV, Postgres Hacking with Andrey, Kirk.
Hi everyone.
Hi Andrey. Hi Andrey. Hi Kirk. Thank you for.
Yeah, long time no see, but we are doing this again and again. We won't stop.
First of all, congratulations with first work committed to Postgres 16, right? We have /watch second command, or it's not already second because you have parameter there. So I didn't follow the end of discussion and didn't test the final version.
They changed it from just second parameter to allowing it to be a named parameter. So you can say I equals for the number of iterations, which actually allowed it to be done in either direction. You can do the sleep amount and the iterations in either order now. But it's actually interesting because it kind of allows a for loop. If you think about it, this allows you to do effectively a for loop.
It opens new doors, actually. Adds flexibility and so on. It's similar to normal SQL or PLSQL functions where we also can have named parameters and we can use any order of them if we use names, right?
It's a neat idea. I didn't understand it actually. So we can add a counter to parameter in PSQL. So it won't select one, it will select 1 to 3, like that.
Like variable.
Yeah, it's not that it doesn't give you a variable, but because you can now say, watch this 6 times, you could actually execute a query 6 times or a fixed number of times, which effectively gives you a weird for loop that you could use to execute a query so many times. So for example, the example that was used on Nikolay's website about looping over and deleting records by using a with clause and reducing it with a limit and then deleting them in chunks. Well, if you knew you were going to delete 20 chunks worth 5% at a time, you could literally watch that statement 20 times and know that it would complete all of your deletes for you,
but
which is without the full loop. Yeah, without the full
loop. The statement should be stateless, right? It should not have any
right. The statement,
context.
Yes, of course. Right. The statement would have to be, stateless in order for it to work.
And we can add this variable like counter to the query as a PSQL parameter.
Oh yeah, that gets a little harder because the challenge is there's no way to change it. This is what I thought of. I usually use gset /gset to set a value, and there's nothing changing our internal count. But we could start by passing it as a colon PSQL variable, where iterations equals whatever the count is, but it's only going to grab that once, and then it's going to be in a loop for that number of times. It's not like you can manipulate the loop variable once the loop starts.
To manipulate, you need to use like current setting and set config SQL functions, so you can pass and you can increment it and so on. But yeah, and also PSQL has if else.
Yes.
Like, so it's already like some kind of a language inside PSQL and
meta command will be Turing complete.
Yes. Yeah, there you go. Here's the one that was interesting because we've mentioned Tom Lane before. 2 things he pointed out that we learned from. One, he cleaned up the code a little bit before he pushed it in for the commit. But the other one was he recognized that the first select statement with the semicolon, then the wait, /wait, we had tweaked the iterative count because we didn't realize the first semicolon was causing the first one. And so he made this comment on the piece where he committed it, which I thought was fabulous. This gets back to people reading the Hackers News pieces and stuff, because he made it work the way other things worked as part of the process. And that integrity is very important. So kudos that he saw that issue. Leave the semicolon off when you do the /wait, and then the iterative count will guarantee you only execute that many times. If you add the semicolon, it executes it first once,
+1. Yeah.
Then the wait executes it for the number of iterations.
When I started to use /watch, first couple of years, I didn't know that semicolon is not needed, and /watch /watch is itself semicolon, so it's like end of statement, and that's it. So you don't need semicolon.
We can actually watch
it took
the
just a couple of
commit.
years. For Andrey,
Yes.
I guess it takes like 10 years maybe, because I think 90% of people don't know it. So,
Right.
but with
And I was in that boat.
iteration makes you think about it, because y+1, and that's why, right?
Yep.
Okay. So
We can actually look into the commit as it was done by Tom Lane. So I'm just
and review it or
scrolling
what?
through it. Yes, and see what we have done wrong, what he changed. He completely rewrote commit message. There is no single word that I use.
I think it's good work. We should do it, but we need to limit
Not now.
ourselves in terms of time.
Okay,
Maybe
makes
next
sense.
time or
Okay.
yeah, because we have interesting topic today: observer effect. Observer effect is when we want to understand what's happening. We start using some measurement tools, and then they change the picture. For example, I remember when PG-star statements first became a thing, many people had fears that overhead from using it is too high. And I remember there was some discussion, it's, it's like 7 to 10%, but it's worth it. So it's significant, but it's worth it. Now, since like from practice, we know PG-star statements definitely worth having, already discussions had ended. Like I don't see big discussions around PG-star statements overhead, but there are some edge cases or corner cases, and we will be talking today about them. So definitely very good measurement tool usually has some price, and you need to pay it. This overhead in terms of CPU consumption and so on definitely exists, and it's called observer effect. And there is also an interesting extension called pgstat-kcache, and recently we saw overhead from it as well. Why pgstat-kcache is needed? Andrey told me that being a user, Andrey doesn't understand. You don't understand why it's needed, right?
Yeah, I have no idea. Like I observed that we use patched kcache that is measuring something splitted by query parameters, but that's all I know about kcache.
Right, and actually this is a very different topic, and this could be done with PG-star statements as well, but it's very different topic. But let me explain why pgstat-kcache is needed at all.
What's the difference between kcache and statements? What's there?
PG-stat statements is very high level, time oriented and frequency oriented, or also blocks oriented,
and IO oriented and wall oriented.
No. IO there is a number of blocks hit and read, but it's for buffer pool only. pgstat-kcache extends it with metrics for disk, physical IO. Physical IO. So it provides you real disk metrics. The same you can do observing proc manually using process ID proc, and you can see how many IO operations happened with your disk. And so it's underlying operations, because when PG-star statements say reads, it's probably from page cache, from memory, not from disk. Sometimes it doesn't matter, but sometimes we have we need to distinguish. Sometimes, not often. And also, but timing is more interesting metric. Total time, mean time, max time, all these metrics are not directly related to CPU consumption. Because, for example, some queries might sit being blocked by some another transaction, right, and just waiting. Or we can have so total time is a black box in terms of PG-star statements. We don't know what's inside. Of course, looking at IO numbers gives us, and also frequency calls metric. These two things give us understanding what's happening. But usually, when we deal with like heavily loaded system and see CPU usage is growing, and we need to find which parts of our workload contribute most to CPU consumption, PG-star statements cannot answer it. Wait event analysis can answer. But as I recently realized, for example, PG wait sampling, very good extension. There are two good extensions, PG Sentinel and PG wait sampling, which provide you wait event analysis. PG wait sampling cannot give this understanding because in Postgres terminology, CPU, which you can see, for example, in RDS Performance Insight, CPU, like green area, it's like CPU. For Postgres in PG activity, it's null in the wait event. And PG wait sampling doesn't capture samples for it. So PG statements cannot provide you answer to question which queries contribute to CPU usage the most. And
Let's
wait
just
sampling
fix, one day we should fix this in PG wait sampling too.
Yes, I think so. There is
CPU consumption is null in wait events. That's true, but
exactly. But there is an open issue. Yegor Rogov opened an issue there, but it looks like it's not easy to in terms of PG wait sampling code. But it's another story. PG Sentinel, by the way, replaces null with CPU, the same as RDS guys do, and some others also. And it's useful because for users, for end users, the question is which queries contribute to CPU usage. But pg-stat-kcache, why it's interesting? It extends pg-stat statements with metrics CPU, but not only CPU. It goes further and says user CPU and system CPU, plus also context switches, voluntary, involuntary, and so on. So like it's many details about, and also everything is grouped by queries, the same query ID from pg-stat statements, so it's extension to pg-stat statements. I believe you cannot install pg-stat-kcache not having pg-stat statements, so there is dependency here. So, but the problem is pg-stat-kcache has significant observer effect if you have a lot of TPS. For example, if you have like 30,000 TPS, 50,000 TPS, the contention between pg-stat-kcache measurements starts. You can see it in pg-stat activity as a special wait event called pg-stat-kcache. So it has its own wait event, and you can see it in pg-stat activity.
So basically, you have a lightweight lock in both stat statements and stat-kcache, name it after the extension. And when you are manipulating with, when you have contention around manipulation of internal structures of kcache, you see it in wait events.
So it's fighting with itself, I guess, right?
Yes. It's not locking with something inside Postgres, but on its own data structures.
That's why that's why it's noticeable only when we have a lot of TPS, like concurrency.
Yes, I will demonstrate it with 2 p-sequels.
Okay,
just a little bit later.
So, sorry, Kirk, you wanted to ask something.
No, I was just to reiterate. So the observer effect, like the Heisenberg uncertainty principle, trying to measure something that you're actively running is hard. And the first layer of impact is it takes some of the CPU away from what you're actually trying to do. That's the 7 to 10% you mentioned. But there's a second thing, and that's actually what Andrey just touched on. And that is internally, it has to have locks. And you got to consider that it's potentially multi-threaded, because you have different sessions trying to do different things. So if you have a session that's out there monitoring and logging, and you have a DBA who's doing his own pg-stat statement stuff, now you have contention between these two, but you also have contention with any locks that have to be placed by the core product while it's doing its thing and updating its structure. These guys don't use regular tables. They use in-memory structures, hash tables, things like that. So they use lightweight locks to protect it while they're giving it to people and while they have to update it. So the challenge becomes is you can put yourself in a situation unplanned where you start locking and someone else wants to lock. And now you start getting into race conditions and, the semaphore problems, potentially. So that's interesting. So there's 2 different types. We are all okay with the 7 to 10% overhead, the impact it has on our system because it works. This type of lock, though, can potentially stop, as we see in the complaints, any other SQL query from running because it's waiting for pg-stat statements internally. Is that about right? Did that summarize that okay?
It's about that. With pg-stat statements, I had the story also related to this contention, like internal contention for shared memory. But are you okay with this terminology, by the way? I always wanted to ask, when we say lock, it can be heavy lock, right? Lock for like database object or row or something. But when we say
transaction
lightweight lock,
table or something like that.
some systems call it latches, right? When we talk about physical, is it okay to continue saying, like, Linux names it lock as well, right? So okay, I just wanted.
Yeah,
to
I think the concept is lock, but you're right. When we're talking an LW lock, that's a lightweight lock, and I think in the Oracle terminology, that's a latch, right? Is that
right?
Yeah, and some people are more used to that's very much a super fast kind of lock, and it's not designed to be held very long. And therein lies a couple issues, because the minute you get enough work on your database so that the number of rows coming back is too large, which all starts playing into what causes this. When you start writing to disk, you're not supposed to be holding a lightweight lock while you're thrashing your disk.
You actually can.
Well,
let me describe. So today we are going to talk about lightweight locks, and they have like two properties. First, both properties are properties of the interface. So first property is they are manipulated by a core developer, not by DBA or data schema author, but developer of extension or Postgres core.
They are not user facing.
They are expected never to be guaranteed never to have a deadlock. That's first. And the second feature is that its API is expected never to have a timeouts. So you should guarantee that they do not have leave lock too.
So it's not a good idea to create LW lock timeout.
Yes,
setting.
there is no timeouts in the API, and actually many people, including me, asked for this, and Tom explained it us very well that there will be no timeouts, because if we invent timeouts there, we will have to invent timeoutless locks somewhere deeper.
Right. Okay.
So let's move to locking of stat statements.
So we have two extensions and similar problems on both, right?
Yes, they share some like set of developers. One, as I remember, is Julian Rohound. I'm not sure how to correctly pronounce his name. Sorry, if Julian for some reason is watching us.
I remember only nickname Rjuju, or how to pronounce it, right?
Juju.
Okay. So, yeah, it's a bad pronunciation. Sorry for guys who are watching.
And I know that there are many developers who work it on pgstat statements, but I just don't remember others. Sorry. And these kcache and stat statements share locking schema and share internal idea of internal hash table that translates query to some information about a query. I'm not really knowledgeable of what exact information is there.
Is this data kept in the same buffer pool like normal shared buffers, or they have their own area in memory? Their own
no, it's not in shared buffer, but they are in shared memory, in shared hash table.
Okay, I see.
I can show it. Let me share my screen with some code.
So Andrey, what I'd like to see is create the problem, show the lock, and show how everything locks up first, and then we can. I think you can attack it from that standpoint.
Yeah,
that'll put everyone on the same page.
Yeah, I had a very similar problem in stat statements to the problem which Nick is explaining. So let me show. Here is my post to hackers about it 6-7 months ago. I think we can attach a link to a video later, and I will just redo the problem which is here, which is described here. So in stat statements, we have a lightweight lock. Let's see it in code. Yes. Here, shared state, which have one lock which is protecting hash table. And this lock is taken by every read of our view. So if we are executing, for example, select from pgstat statements,
And it's very long. If I mean they're very big, it take during like I remember this. Oh, sorry, I won't be interrupting. I will explain my horror story later.
Sorry, it's slightly I have slightly modified code here. So this log is taken when we are reading from stat statements. I have modified this view to be hanging a little when we are doing read. Why I have done so? Here is the code which is doing acquire of log. We are doing just shared log acquisition, and I added sleep here. Why am I doing so? Because in my incident, we observed that when we are reading from pgstat statements, it actually can write a little to disk. How does it happen? When we are selecting from this view, we actually have to form tuple store. Let me show it. Here we are doing tuple store. Here we are copying data from our in-memory hash table. We are copying it to tuple store here. This is a result of a query that will be transferred to user. So user told me, please show me statistics. This statistics is in memory, but to show it to user, we have to copy it to tuple store. And if the size of a tuple store is more than working memory, Postgres will have to materialize it on disk. It is a very teeny fraction of data, say, like it's less than 1 megabyte. But if you are doing again and again a lot of reads of stat statements, they can create some I/O, actually, some writing on disks and reading from this disk.
Is it temporary files or no?
Yes, it will be temporary file. And
so we can see using pgstat statements. We should see ourselves like select star for pgstat statements registered by pgstat statements, and we have metrics for temporary files, right?
Yes, probably we
should observe effect ourselves, right?
Yes, we can observe effect of observing with tools for observing and like recursively deeper. But let's see what effect of this we can observe. Let's say that we are doing here, we are waiting here for 20 seconds. Here I'm adding a call to function pgsleep with argument 20 seconds. Let's install it.
Is it for demonstration of contention, just for debugging purposes?
Yes,
right?
For demonstration of contention, sure. So when I am doing select from pgstat statements, it is having a shared log for 20 seconds. In this time, during this time, when someone asked system for selecting from pgstat statements. Now database is operational. We can select something, but we have shared log. And if at the same time someone is trying to reset stat statements.
No. Okay, sorry. Yeah, okay, sorry. I cannot keep it inside because I had the same problem, but without this work mem bit, not understanding work mem bit. So not
look, see this data, few bytes here. So contents of pgstat statements fits in memory, but before sending it to the client, Postgres have to materialize it in memory. If it fits in memory, in work memory, if it doesn't fit, it will create a temporary file before sending to user, to client.
Let me explain what I wanted. When reset happens, a lot of new entries should be registered in pgstat statements, and
yes,
it cannot be done while someone else is reading it, right?
Yes.
If someone is reading, shared log is acquired, or how's it called? And if different session tries to perform a query which is not yet known to PG start statements, and it should be inserted there. It's been blocked.
Yes, it will.
Because we are still reading, right?
Yes.
But reset, it's a good way to demonstrate it.
Okay,
but there
let's
is another
use
way.
select now.
There is another way to demonstrate it. Any utility command like set application name to some random value. This is what happened to me. Java code generated
set something.
Set application name to some value, for example. This will go to PGStar statements, and PGStar statements doesn't normalize this. Doesn't normalize set
Like
comments.
that.
Right, and if values are new all the time, set application name to some new value. It will try to register
Can
new
we do
entry.
something like that?
Yes, yeah, to text maybe. Well, you cannot do it probably, but
yes, we can't evaluate functions here.
But in my case, it was application name was set to some Java code was setting it to some, like session ID equals something, and it cannot normalize it. Right.
Let's see. We have 20 seconds to reproduce the problem. So I've looks like I messed everything. I just
write some any random value.
And somewhere we are doing select. Now every read query is hanging. And system is absolutely not unresponsive. You cannot restart it. You cannot do anything. Let's prepare it again. Some application name that will have to be entered to a hash table. Reading of all full stat statements, and then simple query which should just work. Again, reading from stat statements. New query, and the base
maybe
works.
It was not new. Maybe you used that value in set.
Yes,
already.
seems like.
No. In set command, you need to.
In the set command.
Yeah, set commands.
No. It just both queries have to be new.
No,
Oh,
sorry.
No.
I think what is hanging is a query which is not yet known to PGStar statements because it tries to be registered, and it waits until our select star from PGStar statements is still working.
Okay, let's try again.
If you use query which already used and is known to PGStar statements, it will be fine.
Because I think what we're looking for is the lock on the structure to add a new item to the structure.
Exactly.
So,
And set command is not normalized. That's why it's becoming hotspot because every time it's new, if value application name is new, it's
I think with reset I had something harder. Let's try with reset.
All queries are new. So
I think reset works better because it shows the interaction more directly.
Let's try again. So reading from stat statements, resetting, and now even no, just new queries. Just new queries are hanging. I could achieve the situation where no query is working and you cannot even disable stat statements. So it's just hands. And the database is fully bonked. Totally.
So in this case, what we just witnessed, though, was it actually did work. It just had to wait until the lock was released because you had a 20-second delay on the lock. So in this case, when you ran your lock, it acquired the lock. Then executing the select statement with a new value, it went to insert it in the structure, and it got held up by that lock that was in place. It queued up, and then it eventually finished, right? But this is a minor version of this because if you have something in the background that keeps queuing up requests against this, that's what locks kind of everyone out, is that you never end up getting out of the lock situation.
Conclusion, don't run reset. Never.
Don't run new queries.
Don't run new queries. This is a broader explanation, right?
Yes, it never hangs if select doesn't get used.
And
let's
disable
try
track
to
utility
reproduce the
because
same with stat.kcache and then fix it. Does it sound like a good plan?
Sounds good plan. Yeah, there are many things we can discuss this. Like because I remember that horror story during Black Friday.
Just let me just remove.
By the way, track utility can be off. In this case, set is not a problem, even if it's random all the time. And as I remember, in Postgres 15 or 16, a normalization was created. So all set comments, set application name to something, it's now like set application name to $1.
Okay, we are going to fix it in stat.kcache.
Okay,
so I am removing stat statements from.
You cannot. There is dependency. You need to have both.
So I have to fix. Okay, and in which order I should have them? The order was correct.
Doesn't matter.
Stat statements. Stat.kcache. Okay, so anyway, let's fix it back. So we remove sleep here and break kcache. We should find where we are looking exclusively in reading. Here is a store of new query, but we need to find where we read query.
I think the problem. Oh, by the way, PGStar statements they don't have their lightweight logs. They are not named in wait event of PGStar activity. It's not named like PGStar statements.
They are named,
right?
For sure. I checked it.
So it's like you can see it like PGStar statements, right?
Yes.
Like this.
Let's add wait here. So here is pgstat.kcache internal and pgstat statements internal. So they are so resemblant. They are very, very, very similar. Even functions are named the same way. So we are adding here sleep under the lock. Now pgstat statements should not wait, but kcache should wait. Let's try it. We need to install both of them. Install pgstat.kcache, make install, and restart Postgres. pgctl test installation, restart. Now, when we are selecting from stat statements, it's select instantly, and stat.kcache should wait for 20 seconds. Resetting stat statements is just fine. PSQL reconnected here. Resetting kcache should hang. Yes, it's hanging after the same lock. And let's try again. When we reproduce this problem, regular queries will hang. Any new query will hang because it's trying to enter new information into stat.kcache.
Same problem. I have another solution. Don't read from it. Never. Don't read from PGStar statements. Disable monitoring.
Totally true. And it's not don't read from stat.kcache. Don't read from stat.kcache with a small working memory. If you have huge working memory, you never end up writing to disk during this.
Well. I don't agree. This problem, writing to disk, it just makes the problem bigger because
true.
If I'm reading, if my memory is enough, big enough, but I'm reading a lot of data, it still takes some time for me to read it and to communicate. If I'm reading, maybe if my client is very like far from the server, while
I
I'm
think you can reproduce the problem with writing just to memory without disk, but it will like on order of magnitude bigger,
right.
like more pressure at
3
system.
orders of magnitude bigger. I understand this. Yeah.
Yes.
So
yes.
could we alter the apply an alter statement to tell it to use a larger work mem when we're pulling stuff from stat K-cache statements, or right?
I think it can be done for
Only
for
for
example,
procedures.
if you have monitoring user, you can alter that role and give more work mem for it. I think it's possible,
but
right?
they will
if we
consume this
wrapped it in
memory.
a procedure, the procedure could have an alter applied to it that would change the work mem while that procedure was being run, right?
Right, but procedure functions.
Yeah,
we don't have to run procedure. Actually, we can just say
it's another
here,
story.
work mem plus plus.
I think
like it will work.
As someone who spent recently, like a few days ago, 5 hours to understand why wrapping some select star from pgstat something is a very bad idea. Just don't do it, because upgrades will be a problem. Dump restore won't work and so on. Like I probably need to record the explanation why it's a bad idea. And
okay, so let's just fix logs.
But raising work mem is a good recipe for current state, right? So to minimize this problem.
We can just replace acquisition of this log with conditional acquisition. So what happens if we cannot measure? Yes.
Sorry, Andrey. So we saw there is a problem. We discussed how to mitigate it at least partially. So bigger work mem, disable utility, track utility, reset less often, read less frequently. Right? There's a bunch of recipes here. Not all of them are not like ultimate recipes, like not solving problem final state. But now you think we can improve the behavior, right? Is this?
Yes. Yes, I think so. But like Julian might disagree with my solution to this problem.
Well, something else in the bug report, it was mentioned specifically that PG Watch was actually doing a lot of work in the one Andrey reported. This is a great example of have PG Watch have a larger work mem if that's a risk. And then I'll leave the whole work mem thing alone, right? So since we were just talking about workarounds, it is context is important. And so if you're monitoring stuff with something like a tool like PG Watch, then this should be elevated a bit insofar as your awareness that, hey, this makes sense to have more work mem so that you're not going to disk with your results before you come back, and so you don't put that extra pressure on. Now, that said, I'm curious to see your changes. And could you close that screen on the bottom that's asking you to restart your Visual Studio? I'm like a type A person, and it's distracting. Thanks.
Sure. So let's just sometimes we are acquiring expensive log. In reset, let's leave it exclusive. Here, we are going to enter new entry into a hash table. What happens if we cannot? If we have a contention, we can just skip it. Just don't do it.
Not this time, right? Not this time.
So we can safely just return here. And if we can replace acquire conditional log, I just don't remember how it's called. Log conditional acquire.
Conditional acquire.
And it is returning us if we succeeded. If we did not, just return. Do nothing.
We cannot specify any timeouts here, no?
No, that's fine though. So, but I get the gist of this. This is saying that if it's a choice between being able to track a new query that was created and potentially hang trying to track a new query that's created, then let's not track this query just yet. And if it gets executed in the future, it will get tracked. I don't know how much else doesn't get tracked now because we didn't add this to the table. I'm assuming that it won't gather any stats because it won't know anything about it because it doesn't exist. I'm concerned in the back of my mind that maybe there's other code elsewhere that keeps trying to add it. So this code may be getting called
do
1,000
it as you
times.
say. Not really difficult to do that.
10 attempts. Okay. But by the way, I cannot understand how someone can dislike this idea if we make this behavior not default. For example, we can introduce another GVC setting and say, you choose. Like track everything always or best effort tracking.
Honestly speaking, I didn't pursue this idea because like I was doing it last September. It was simply difficult month for me. Maybe this is actually not that bad idea and we can try to push it. At least
may I ask if
Kcache.
someone is using this approach, like patched version of PGSA statements or Kcache in production already?
Yes, I know one cloud provider who is using patched stat statements, but unpatched Kcache for some reason. That's just how things happen to be. So if I equals 9, sorry, it's hacky return. So if it's 10th attempt which failed, we just return.
Return. I'll go outside of function, right? I see.
Yes, and let's do the same. We can add some sleep here on 7th or 8th attempt.
Yeah,
like 10 microseconds or so.
I'm going to look for this and replace same in reset with the same cycle. I'm not sure 10 is a good number. I feel that actually 42 is better.
But for reset, we need to return false to the user because it's user requested it, right? And if we failed, we need to say we failed. Unlike
it's void. There's no return.
Yeah,
I think I can let me
produce
fix
warning.
the problem of numbering and get back to it later. Here, where we are using void. It's void, yes. Reset is void. I can emit a warning here.
But I'm not insisting. I just generating some ideas.
Let's do it. I like login.
MVP is better
warning.
actually. But
to acquire log. No reset done. Sorry. I'm not sure. Is it good to be polite or we could save a few bytes?
We should always start. I could not reset. I'm joking. So let's
you can leave off the sorry. You could leave off the sorry, but failed to acquire lock. And I would say reset not done, as opposed to no reset done. That's rough English. Unlike the 36 cases of a noun in Russian.
And not local LW lock, but okay.
Let's try to reproduce it now. Let's try to restart.
Well, we didn't add any kind of sleep statement. So considering we have a 20-second sleep to kind of help trigger this.
We still have sleep. It's still there.
Yeah, no. We don't have a sleep in our loop of 10. You didn't add a small sleep in the 10 in the loop of 42 times. So without that, it should still end up with the same problem, right? Because it's just going to quickly try to acquire the lock 41 times in a row.
Yeah.
With
actually, I'm just thinking where I can steal a code which is doing sleep for locking purposes. I saw it somewhere in SLRU Sync SLRUC.
This is when we would like to have communication with ChatGPT, like show me parts of PostgreSQL code base
No,
where
it's not here.
this
I saw a slip in SLRU. Maybe it was in multi-exact. Yeah, PGU sleep. We can use PGU sleep.
Cool.
Conditional.
Acquire.
It's stat statements. I need to, not in stat statements. So if I is more than 20, I know, sleep for 1000 microseconds, 1 millisecond. Sounds okay? Like in 20 milliseconds at maximum.
we should implement exponential backoff and jitter.
Oh, come on. Let's just, okay. All right. The way things should work is we get it working, then we improve it.
like okay, not exponential, but
there you go.
No, it was a joke. This is 1 millisecond, right? It's too high for these purposes. Or this 1000, is it?
There you go. Yeah, that 1000 was equaling 1 millisecond. So now it's better.
It's not real math, but let's leave it here. I hope, Nick, you won't use it in production, right? This way, and think a little bit about this numbers that we just took out of us. I know how to say it.
This 100L, is it milliseconds or microseconds?
Microseconds. It's microseconds.
So
yeah. So it's 100 microseconds times I.
It's too high.
Let's compile it. I'm not sure it will compile without warnings. It does. Make install. So restart. Connect and reconnect. Try to hand now. Reading. Long read is taking exclusive.
Oh, good. See it failed. See it saying reset not done.
Yes, it cannot take lock for long. But let's break back reset.
One second. This failure happens only if someone is reading from pgstat statements or pgstat kcache in our case. But who can do it? Only some monitoring tools or humans, right? That's it. I mean, it's not a very frequent situation. If we try to reset, we fail. We know someone is reading in 1 minute or
let's break it
10
back.
seconds. Probably no one will be reading, right?
Let's break it back. Let's do reset unconditional. It have to acquire the lock, and it will actually, in fact, it is queuing itself after shared lock, thus escalating lock effectively. Because when it is holding when it is trying to achieve exclusive lock, no new shared lock can go before it. They will queue after exclusive locks. That's an important part of the problem, actually. So we are breaking back reset to emulate the problem. Again, reconnect everyone. History is resetted. Select everything from PGs.
You should start using exclamation mark.
It's not compiled in the mile build. I know how to use it. And select pg.kcache reset. It's hanging now.
Oh, no, it's not hanging.
It's not hanging. Why it's not
hanging? It launched the error message. Did you properly? Oh, you fixed it. Did you fix it in Stack Kcache? Yeah.
I said install. Try it again. I didn't restart. I had to restart server, so it load new shared object file. So now reset hands, creating the problem.
No, this is considered as same because you change value, it's the same normalized query. So try to use like multiple columns. It will be considered different query. I think select two and select now probably is...
It's already exited.
Okay.
We need to, like 20 seconds seems not enough.
Not enough. Yeah.
We don't have logins there. It just works, but we need login
but we
to
can
show
check
us.
the content of pg.cache or statements, right? But it's
Let's just add logins there. I think it will work for us. We should not use it in production with this login because it will produce, because it will emit warning to innocent query. Could not enter a query for information to .cache. We could in production we could say debug 5, and that would be okay. Let's do it this way. I think it's.
But we will see a lot of debugging.
Yeah, you'll have to. Yeah, you have to see a lot of.
Leave warning. I promise I won't be using it in production. So.
This today.
Today, before noon.
There's stuff. Set. So we see the warning that query could not be entered, and it executed. Seems to work.
So this proved our point is that, you know, we've got a spot. We went to add it to the structure in memory, and then we aborted that process and just continued along and let the query run.
Yeah, I want just to see how much actually time it took to give up entering in the .cache.
Yeah, good point. Could we log twice on that?
About 73 milliseconds it tries.
A lot.
So if everything is broken, you're not adding more than 73 milliseconds. Actually, this is just too much, I think.
I agree.
But do the same select again. Do the same select again, just the same one. I want to see. This time it didn't complain, it wasn't running, right? Now select one won't work because it's already in the log. So select something else. Yeah. There you go. And it'll keep doing that until it enters.
We could use actually watch here. It entered already. It just finished it here.
Yeah.
So this can be done with a patch to .cache. Should we print the stuff?
Yeah. But I would do it configurable and maybe not default behavior first.
Okay, but I think we can just
it's okay. I'm just, for MVP, it's fine already. Just probably you demonstrated the problem using a couple of sessions. I would probably check this patch behavior using pgbench and like many TPS, many sessions, many clients.
Okay, so I'm unbreaking reset back and leaving warning here if everyone's agree.
You know what? I wonder, maybe we fix different problem because in my case, yeah,
but there is nothing else protected by this.
Right, but think about it. We had pgbench running for quite a long time with a few queries, which are like normalized queries, only a few of them, right? And then when we had a lot of sessions, clients, and a lot of TPS, we observed this lightweight log from pg.cache. I wonder why it could happen if we used only a few normalized queries.
You are observing the log, which can be contended only if someone took exclusive log.
Yeah, I understand that, but still.
So there is nothing else to log here.
If the table doesn't change because it's all queries already normalized.
Maybe some monitoring called reset. Maybe some monitoring
No.
Maybe something else emptied the hash table and new queries started to be added there.
Well, worth additional investigation, but yeah, I now have more data to
yeah,
continue.
probably chances are that we fixed the wrong problem, but I don't know what to say.
Oh, I think I will just test it.
Unneeded spaces. See that this red line here, it's spaces, which is, I don't know, for some reason we tried to avoid it. And this should be avoided too, this sleep. So
Yeah,
I'm just
it's
formatting final version.
So in summary, PG stat statements and the PGK cache, they use a memory structure, kind of a hash table memory structure, in order to be able to update the statistics very fast without having real tables, locking transactions, and all of that. So they update their memory structures in memory, okay, using these locks. And in order to feed that data back, they have to convert them to tuples. When they convert them to tuples or tuples, if it exceeds how much they can quickly store in their work mem, then Postgres is forced to create a temporary table effectively and write the tuple store to the temporary table and then serve the query from that location back to the user. That is orders of magnitude slower than memory. And that adds to the contention problem on how long we're holding these locks while someone may be waiting for an exclusive lock, etc. So what we did was we effectively found the one spot where we know an exclusive lock is forced to be acquired because we're trying to add something to the table. And we added a workaround to make it conditional so that it could time out and not add the new query for tracing reasons to avoid creating the problem. So,
right.
Summary.
Great summary. I just wanted to emphasize that when some normalized query is already known to PGStat statements or PGStat cache, and we just need to increment metrics, there is no exclusive lock, so it's not a problem. The problem happens when someone is reading for a long time because of probably not enough lock mem, and another query tries to insert to bring new entry, and this new entry problem. So, yeah.
Yeah, because it's in memory structure, right? And so trying to modify that while it's in use, frowned upon. Acquire your real lock and then do it. So, no, good. I'm sorry, Andrey.
I just, that's all I wanted to say. So, should we send this patch to Kcache maintainers?
Yeah, probably. Let's open a pull request because I guess it's on GitHub and we can follow. Like we can, or should we send email with patch or we can open pull request, because pull request discussing pull request is easier, and I can promise to benchmark it and see if we
maybe
solved
for
our
benchmarks
problem.
You can do just one unconditional attempt.
Yeah. We're removing loop. Yeah. Why not? Yeah.
I've sent you the patch. I think we can publish the patch somewhere. I have no idea. Pull request.
Yeah.
So
and I think,
should I do the pull request or you can do it
as you wish? As you wish.
I know.
I think if it's again, if this idea is like can be managed by DBA in terms of configuration, Postgres PGStat cache configuration, and you can choose what you prefer. You prefer like reliable observability, but with some observer effect, or you prefer to get rid of this observer effect, but sometimes miss some entries, right, for some period of time. You can choose, and if this is a very good optimization, I think. I would on very heavy loaded systems, I definitely would choose for both PGStat statements and PGStat cache. I would choose best attempt approach to get rid of observer effect. I know these queries will come later and be registered anyway. So, yeah.
So there's a small part of me that says, wow, wouldn't it be nice if it was locked or we couldn't acquire the lock, that we could actually just queue it so that like in the future sometime.
Insert to table.
No, not a table, right. But yeah, you get into these things, but you have to realize the key aspect of this, of both of these extensions, is it's an in-memory structure to reduce the weight on the system.
Performance.
Yeah, performance is key. And if performance is key, we're willing to give on accuracy. And I agree with Nikolay, this probably should be a GUC or some kind of setting so that the users can choose. But just so it's obvious they're choosing. And at the same time, for me, the choice is obvious. Don't track the new statements. I'd rather lose that.
And probably if it fails to insert new entry to either PGStat statements or PGStat cache, it could be maybe
Create
not
a
warning,
log.
but notice maybe, because like it's like
driver will implement it and show it to user.
Or maybe warning.
Get scared of it.
Throw it to the log file. Throw it to the log file and let the log file know what happened. Is that reasonable, or is that still too heavy?
Maybe notice because maybe
rate limit noticing, like say that 1 in a million queries is logged to the log file.
Sample noticing, or warning, sample logging.
Maybe I just like
over-engineering.
Too payloady.
Yeah, that's why notice, because warning is what I would like to see always. If I see too many notices, I probably will go down in terms of log min messages and don't see notices at all. And in this case, I don't log it. I don't log. Okay, these are design decisions we can discuss and pull request to follow up on and so on. I hope. Yeah. Anyway, I promise to do benchmarks, which will show that indeed PGStat cache, like if you don't solve this problem, what my impression right now is it's fine while you have not many TPS. When you approach your limits, you have like performance cliff basically. Any spike can bring you down much quicker than without PGStat cache, and this is not good. So under like on our edge, we are in worse position, and with this fix, I think we should be in good position. We will see now in benchmarks. Okay, it was fun. I also need to mention that we had Jim stopped by in the beginning, saying thanks for our support in the XML indent patch, because it was also pushed a few weeks ago. So we have indirect contribution because I know Jim was inspired by our session to contribute first patch, and it was pushed. That's great. I feel a bit sad that our timeout transaction timeout patch was not made it
maybe 17.
Yeah, 17. Yes. Anyway, what this XML indent, it's good things. So encouraging to continue. Thank you guys a lot. As a reminder, those who reached this point, please, you know what to do, like buttons and so on, and propose ideas, feedback, and participate somehow. Appreciate it. Again, have a good rest of your week. Bye-bye.
Thank you. Bye.